Okay, so for this question, we need to utilize the ray approximation to work this out. So we have a light source. We can see that the light source is coming from very, very far away. And what this basically means is that we can assume that the light rays are coming in parallel, just like this. And what we have is it's interacting with these two obstacles. Now you can see that the gap in between these two obstacles is 10 centimeters, and these are 25 centimeter obstacles. And these are significantly larger than what the wavelength of light is going to be. This is light, so it's either, we can assume visible, so between 400 and 700 nanometers. So this is much, much larger. So therefore, the ray approximation is valid here. Okay, so we're taking y to equal 0 on the wall, which is 1 meter away, and vertically equidistant from the edge of each obstacle. So here, it's in the middle, in between here. So this gap here is going to be 0.05 meters. Where is the shadow in y coordinates that is cast on the wall by the upper obstacle and the lower obstacle? So using the ray approximation, if we're assuming that the light is coming in like this, that would mean that this obstacle here is going to cast a shadow. The light is going to do this, approximately what I'm doing. And that would mean that this is going to be in shadow and this is going to be in shadow. And since we know that this is 10 centimeters, therefore we have our y equals 0 right in the middle. Therefore, for the upper obstacle, it's going to be, well, the lower bound is going to be 0.05 meters, and the upper is going to be the 0.25 plus 0.05, so it's going to be 0.3. And for the lower, it's going to be negative 0.05 down to this should be negative 0.05, and this should be negative 0.30. And that's the answer to this first part. Okay, so then this next part is similar but different. So now we have the exact same thing, except we have a point source, a point light source that is 1 meter away from the obstacles as shown in this figure. Where are the shadows now cast by the upper obstacle and the lower obstacle? So if we consider our point light source, it's going to be radiating in all directions like this. Therefore, we can assume that the ray that is coming up and just clipping the top of this obstacle that's going to dictate where the shadow is going to have a path like this. So therefore its shadow is going to be cast up here somewhere. Similarly with the bottom, we can assume that the lower obstacle is going to do something like that. So its shadow is going to be in there. Whereas for these here, for the inner parts, this is what it's going to look like. Sorry, that one was a bit dodgy, but essentially we're going to have these as shadows now. That's going to be a shadow, and this is going to be a shadow. So we expect our shadows to be significantly bigger than what they were in the first part. Now to work this out, it's just simple geometry, and it should be pretty straightforward. So let's do it now. What we're trying to work out is something like this: y1, y2, y3, and y4. And I think the easiest thing to do is just using our sort of similar triangles concept. So for example, we have a triangle here that you can see me trying to color in. We can use this triangle. Once we know the angle in here, we can extend that out to the larger triangle, this whole triangle here. Similarly here, for the upper part, we have a triangle here. We can work out what this angle is, and we can extend it to the larger triangle to work out where y2 is going to be, because these angles are going to be the same. So let's do that. So for this smaller triangle, and tan theta y1 is also going to equal So that's y1. Let's do the same thing for y2. Okay, so that's our first bit. We have this is 0.1 and our upper value is going to be 0.6. So let's do the same thing for y3 and y4. And I'm not going to do y4 because I think you can see the pattern here, right? They're exactly symmetrical. So if this is at negative 0.10, this is going to be negative 0.60. And that's how you do that question.